morning everyone. So today we are going to see what is the main topic of diffraction grating. Okay, so we already know that what is diffraction. Diffraction means splitting of lights. Okay, so diffraction grating means it is an optical instrument that separates polychromatic light into constituent wavelength. Polychromatic light means different wavelength light. Okay, so diffraction grating means is an optical element, okay, that separate polychromatic light into its wavelengths. We know that different lights have different wavelengths. Okay, so diffraction grating will also be different for different light and its wavelength. So typically, the diffraction grating will have something like 600 lines per millimeter. Like if we see, if this is a, let's suppose we assume that this is a instrument that giving us light. Okay, so if we consider lines per millimeter, natural light if you closely see, we can observe more lines, but due to that space, I have drawn only this was the line, but if we consider 600 lines per millimeter, so you can imagine that how small. Okay, and see, we know that diffraction means splitting of light into its wavelength, and the same thing we noticed in prism also. So in both the cases, the prism and in diffraction grating, we are getting the wavelengths of light. So what is the difference between, what is the main thing that make the difference between prism and diffraction grating? Means why should we use diffraction grating instead of prism? The answer is because in prism we are getting that 7, when we giving a white light, we are getting some light of some proper wavelength, but in diffraction grating it gives significantly high resolution, so that we can learn more and more about that splitting of lights that separate closely packed wavelengths. Means in some cases maybe you can see that in prism may not we can observe more and more about that, but in diffraction grating it gives the high resolutions things, and we can easily study about that wavelengths. So I have drawn one diagram here. So here we can here is the list of wavelength. List of wavelength, lambda, normal to grating. Grating means separation. Okay. So here we can see that each clear space like A, B, C act like a narrow in its own direction. Means we can only draw like there are some certain gaps, but if we consider the light, means if we consider light in a diffraction grating, that is like 600 lines per millimeter, so it will be very small. So like it should have very narrow gap in between them. Okay, and light coming from same monochromatic source, therefore it is coherent. Coherent means like it should have same angle, means the diffraction should have been same angle, because the light is coming from a single monochromatic light, and as I said, the angle should have same as per monochromatic light. So here the diffraction by each slit at some angle theta to the normal will be similar in each cases. Okay. when the waves are reinforce each other, the path difference an, when you draw the diagram, we have an with full number of wavelengths. So that means wavelengths is denoted by lambda. Okay, and from our diagram we can say that n equals to n lambda, where lambda is the wavelength and n is the whole number. N equals to whole number and lambda is the wavelength. And if we consider n equals to small a d sine theta, and d is the distance between the two slits. Okay, so here is n equal to d sine theta and n equals to n lambda. So d sine theta equals to n lambda. So from here, which examination we have asked about what should be the value of lambda, we can easily calculate what should be the value of d, means distance between the slits, we can easily calculate by this formula. Okay, and here are some things we need to know, that angle theta is different for different wavelengths. Okay, means if light is coming from any source, we can say that different lights have different wavelengths because of their speed or velocity mainly. Okay, so diffraction grating separates white light into spectrum. We know that white light is getting separated into 7 colors. It is spectrum. Okay, and thus is more effective than a prism. Means it is more effective than a prism. Diffraction grating is more effective than a prism because it separates light into it gives more information about it. And light need to be focused with eyepiece. Eyepiece lens, we already know. Eyepiece lens of a telescope or spectrometer. After emerges from a grating, means from the source, it should be focused on that eyepiece to get more and more about the light. And large number of lines. If it is a large number of lines, then produce more and more to give more detail and produce very sharp maxima and respective inference. Okay, suppose in examination we have asked that suppose there is a light, suppose there is a yellow light of wavelength light, giving lambda equals to 6 into 10 minus 7 meter, and we have asked that calculate the angle at which the 0, first and second order lines are coming. So you just need to do one thing. You just need to draw that plane, Cartesian plane. See, this should be the 0 angle. Okay, and the next one should be like first order, and the third one is will be second order. If in question if we ask that which of the light is more diffracted, which getting more reflected, so we can easily say that the second order. Accordingly, we can say that if anything, suppose 0 and first order given, then if it is asked which is getting more diffracted, so we can easily say that the first order is getting more diffracted if we are giving the image. And one more thing is here, to calculate D, we can do one thing also. D equals to 1 by lines per unit length. Okay, means suppose we are given with the angle, we are given with n, and we are asking about the lambda, and we are given with the number of lines per unit length, so we can easily calculate the distance between them, and we can easily calculate the lambda. Okay, so regarding this, we have one problem. given that a 300 lines per millimeter is illuminated normally, means we are given lines equals to 300 per millimeter, and with the parallel beam of monochromatic light, the speed order principle maximum is observed that we are given the angle, this is theta equals to 18.9 degree, and we are asked to find the calculate the wavelength. Okay, so we know that we can find the distance by d equals to 1 by number of lines per unit time. So distance equals to 1 by lines per unit length, that will be 1 by d into 10 raised to 6, and one more thing is given, it is a monochromatic light with second order principle. Second order means see, we have learned that n lambda equals to d sin theta. So when n denotes the monochromatic or any other light, so we have second order, so it will be 2. Okay, so we got the d, and now in the second order, so n also equals to 2. So using n lambda equals to d sin theta, we have n equals to 2. So 2 lambda equals to d is 1 by 3 into 10 raised to 6 into sin 18.9. Means in examination it should be like a proper angle, like that sin 60, sin 45. I have just taken for understanding only that it is sin 18.9 degree. Because approximately value is sin 18.9 degree equals to 0.3238. Okay. So if you consider now lambda equals to, so from here lambda equals to d sin theta by, then you can directly do it. It will be, so this 3 into 10 raised to 6 is equal to 3 into 10 raised to minus 6. 3 into 10 raised to minus 6 into sin 18.9 degree is 0.2338. 0.2238 by 2. So its approximate value is coming as 5.390 into 10 raised to minus 7, or approximately 540. Okay, so the main principle of diffraction grating is to separate the monochromatic light and to get more knowledge about that particular light that we are studying about. Means we can use a prism as well, but in prism we will not get that much clarity about the light that we got in diffraction grating. That is the main purpose of diffraction grating. Thank you.